Yeah.
So the talk of this morning is Nuitka, the Python compiler.
Yes, hello. Thank you for coming this early into here. I would like to start out with talking a bit about myself, who I am. My name is Haye. I don't work for a Python company, so this is my private undertaking. I'm doing this in my spare time. I don't have any beautiful logos to present, so I put a test image there. So that's something that I hope will change somehow in the future. But right now I do not have any company support. So I work in the field of ATC, air traffic management. I've been managing projects in this field. And with Python, in fact, I've introduced Python into our main product. And it's used in safety processes for mission critical stuff. It's not just the tool that runs the test, but it runs some actual servers who are essential for the operation of a system. So that is for about 10 years now, and yeah, I started doing Python at that company. So I would like to talk to you today about the goals I find that a compiler should have, because Nuitka is not necessarily the first compiler of Python, but actually when I started thinking about that, I think Pyrex was the only thing that existed at the time. And these are my goals: faster, no language limits, error messages the same, extension modules to work. I've looked at other things during this time when I was considering a compiler should be possible. That's like Guido said, if it would have been easy, we would have done it, right? And all this time I was thinking, well, it should be easy, why is nobody doing it? So I looked at projects, PyPy and Cython. I'm going to say a few things about that. When we're going to look at the differences between C++ and Python, because Nuitka is not translating directly into machine language, but it's abusing a C++ compiler to do that. Obviously, nobody these days would go to the length and do what GCC has. Then there's a couple of problems that I will present to you. Then I think a very interesting content is the sessions I've learned, the lessons I've learned. I have some surprises about Python, things that I learned when running test suits that I thought could not be true, but are. And reformulations. I've learned to translate Python and a view of Python where I see constructs in Python and even translate them to simpler constructs. And then I will present you the project itself. We're using the Git flow. We have a plan, status. Very important for me is join. That's one of the purposes here. I would like you to join, ideally from other projects too, but I don't think that's just going to happen just yet. And then I have a license change. So, goals for a true Python compiler. It should not contain any special language constructs. That is, when you look at Pyrex, the first thing that the inventor of Pyrex did was to introduce means how you could specify things in C language and integrate that with Python in nice syntax and so on. It's a very beautiful tool, but I don't like that because it's no longer Python. Also an annotation in a separate file, that is also a no-go. I don't want that. Then better code, even where performance matters. There's a lot of things in Python that when you do it for readability, it hurts performance. I will give examples of these things and show you how I would like to do that and how optimization makes you regress your code. So that will be that. Then I want to, of course, everybody would like to have that. What Pylon gives you normally, the unknown variable, and so on. The Python compiler will likely see what Pylon sees and gives it when you run the program. I'm sure many of you are using Pylon, but to me it's also a goal that when I use the compiler, it will tell me more immediately about these mistakes, so they're even more often avoided. Because you waste the run of your tests, you waste some time. Even if you have an IDE that helps you, this can still be helpful if you did some merges automatic. Then I don't want any limits. What the other compilers do, they introduce limits. They say Python is too difficult. We restrict what you can do. And doing this restriction means that you have only a subset of a language, and the subset it's already good to implement a subset, but you take an arbitrary program from production, you try it, and you find, here it does this strange thing. Do I want to change it just so that this other tool works with it? And do I want to do this for 10 to 20 libraries? I don't know. So, no limits. Then I wanted to keep the original error messages. I don't want to improve on CPython, not at all. I will just be like CPython, and if the error message is not as good as it could be, it still will be the same, so you don't have any transition costs. So, this goal, adding types to Python. So, there's a problem there. People think in terms of C when they want to go this route. I do not like that at all. To me, what I want is that an integer is an integer, a Python integer. And the compiler may use a C integer internally when it detects that this is feasible, practical, may work. But I don't want to say in the language, in my program, that something is a C int, and then suddenly get into problem with overflows. Something which was free with CPython will no longer be if you introduce such types. So the same goes for character pointers. Are they mutable or not? What happens? So all of that is bad. Whole new semantics. Yeah, I place a stop sign there. So that's, I think, really a wrong approach to try and make Python into C just to be faster. It should rather be that you somehow recognize if a performance gain is possible and then just do it, or don't do it if you don't think it's possible. That's one thing. Type annotation is a separate file. You could write down in a separate file, this is a C integer and it's likely going to be C, and I don't like that at all, because it's only effective when you're using the compiler. If you're using Python to execute the same code, it won't know about these annotations, it can't check them, they don't have any impact, they don't have any meaning. So I didn't like that. So often when you say something is an integer, that is an important information to a programmer. If you say this is often an integer, this must be an integer, this could be an integer, this can't be an integer, all of that improves the code quality. So I do really want to have that inside the code and not outside. And actually two files, keeping them in sync, if you do something like merges, for example, you have code merges and you have a separate file, it's going to be a nightmare to merge something that is in two files. I mean, merging one file, it's difficult. So I admit here that I'm personally happy to get along with a single one. Then of course, who wants to learn a new language? I mean, after you've encountered Python, certainly your interest must have died off. Yeah. For me it did. 30 years ago I invented a language and nobody knows it because that was before the internet and was likely not good at all. I think some of these languages that were invented are just horrible. These C-style extension languages, they are just totally unreadable to me. But of course, they do it out of necessity, and because pure Python is not fast enough. And even that horrible anomalation that is not really Python and not C, it's still more readable than C, I admit that. But that's not an excuse. So my goal with the compiler is to liberate these people. It's a laudable goal, I hope. Yeah, don't have to do this just because of it. If you go to a new language, you lose everything. I was at conferences where an IDE developer announced, now we support Cython, markup 2. Well, it's difficult because there's no grammar to fit it, and we did some heuristics and so on, but we now, this one tool supports it too. So that's, of course, a big achievement, but it's an unnecessary achievement, I think. It's something that I don't want. I just want to use an arbitrary Python tool. I want to have syntax highlighting, file-int, dependency graphs, and so on. And if the compiler breaks, or if I distrust it somehow, I just want to fall back to another Python implementation. Be that PyPy, CPython, IronPython, whatever it is. If you deviate from the standard, you just lose. You use the freedom, the tool stops working, and what happens? I mean, PyPy is compatible to CPython somehow, somewhat, and that helps. I think a lot of people, when PyPy does not do the expected thing, will start CPython and check if it's the same. They will not debug PyPy. So, and they have that freedom. So that's a good thing. To do these annotations, I propose a special module to use this kind of hint. Yeah? If you assign x to must be int x, that is basically going to do something like x equals int x, which is a small operation for CPython, but it will raise an exception if x is not an int. And the compiler can benefit from such information. No, that's a Python integer, or at least it casts to a Python integer. So let's look at some examples. Here you see that I'm an ATC guy, meters per nautical mile. So I would write some code and I would do some heavy data crunching with it, and I would realize I have this code and it's slow. It's very slow to use it because of the global variable used. So you inline that global variable and it's a lot faster. But you just gave up on readability. If you look at the second thing, well, the function name still tells you somehow about nautical miles, but the constant itself, it's no longer clear. And you go down this route, and you go down this route, and ultimately you will find out having a function is a totally bad idea in Python. You should just do the conversion where you have a data, when you are even more faster and even less readable. So that's a route. I think there's a tutorial in the other room which I hope will teach only techniques that improve readability to achieve optimization, but I'm not entirely sure that's going to be the case. So these are things that a compiler can easily tackle. This is quite obviously obvious code that every one of you can imagine. The compiler can see this global variable. It's only written to. It's a constant. I can inline it. This function gets called. I can inline that call. All of that is pretty simple and straightforward to see. To Python, it's not. So that's, of course, why you would have to have something that accelerates Python. Then this is another evil thing, len. Yeah, if you do something, decode some byte string, you will use len, and you will find that it's the slowest thing to call at all, because it first does a module level variable lookup, and then it goes into built-in. So it's even slower to call than regular function. But if you do this, if you assign a variable len to len, it will become quicker. Very quick, in fact, because now it's constant time to look it up. These things are, well, make things less readable. Or this here, in my work in ATC, we work with Ada a lot, and it uses this named parameter association. You can use it. It's very readable, because you can make because it's visible, right? Here you see mostly it's the same, but here you have a few things which somehow apparently change their meaning, the semantics. The keyword identifier somehow will be interpreted as an argument dictionary. That is a meaning. If you compare that to the version below, you will have to do a lot of lookup to find out the arguments and what they mean. So I prefer the other version, but it's horribly slow. Each time you make that call, the CPython will build a dictionary. And it will put these strings inside and the values, and the call side gets to look for each parameter, it gets to find it in the dictionary. And then you have to go and check, is it a Unicode string? Is it too much, too many? All of that is a big penalty. That's sad, because this is a more readable way of calling functions. So, less readable code when necessary, worse design when necessary, because you inline functions that you pretty well like to have. And all of these can be handled better with the compiler. So, what I would like to achieve is that performance optimizations in source code, all these kind of stupid things, no longer have a point. The developer shouldn't write integer where it's clear by looking at the source code. There's no manual inlining, no copies of identifiers to local scope. All of that should become unnecessary. I'm totally annoyed from Python when I want to write as fast as possible program, and for data processing you do that normally. And you notice you're not I/O bound, you are bound by calling len or by argument parsing. That's just frustrating. So we're all into Python for readable code, and fast is something that somebody else should do. And the matter of fact is that nobody really, except the laudable PyPy persons, tries to achieve that. And it's also why I think I'm going to work on Nuitka. It's just something that I think needs to be done. But you as an individual normally have very little incentive on working on this. You will just use what's ready. So let me talk a bit about PyPy. I see that PyPy has a presence here, thankfully. So if I say anything totally wrong, just shout out and say stop the crap. Yeah, okay. I will try to stick like that way. I have a very high respect for PyPy. I actually submitted some patches and was in the IRC channel. It was all cool. And actually we met here and I think kind of made friends. As much as you can if you're working for competing projects. Yeah, you get into the situation where you say, I don't believe in your approach, and the other guy says, I don't believe in your approach, and then you fight it out in code, ultimately, over the next 10 years. So, it's a slow fight, isn't it? So it was very friendly and so on. I experimented first with RPython, and I found that rewriting performance-critical parts in RPython was totally possible, and it was even fun to do that somehow for a while it was new. I could add the missing things. I think I was strip, or strip didn't know that it didn't return a string from a character, something like this. Stupid, silly, small things that were missing, but ultimately it came down to being a reduced compiler. I have this nice Python program with meta classes and convoluted object hierarchy where I put things into lists and it generates some code and does decoding. And to rip out the performance critical part and put it in a separate module and compile it with RPython was possible, but it forced me to do design changes which well, they're even still today alive in their code. It's not the ATC operational code, but they're still alive in their code. I'm getting questions, why did you do that? And I explain, I did because of PyPy. And I get questions, what is PyPy? Sorry about that, but I mean, I have to explain, I tried to do that, but I didn't like that route. And ultimately, I found that with reduced Python, it's a good thing, and it could help me write performance-critical applications, but I couldn't reach my goals. You may, I'm not so sure that RPython is as much alive as the JIT is now. Is that a true statement? It is? Yeah, okay. So he agrees with me. I think it dropped in favor because of a JIT. Now looking at the JIT. So my first comment is, but it's not a compiler. Yeah, I want a compiler. The JIT never really knows how far to look, and it's really, I think it's really a religious debate, JIT versus compiler. There's also not a lot of statistical data. I think we have a Java experiment where JIT has quite succeeded somehow. I think it's well accepted now. But there's also a compiler, I think, from Red Hat. So a JIT never knows how much can it store, when do I stop. It has to make decisions at runtime, and it's an advantage and a disadvantage. And actually, you cannot have much influence on that. So other than improving PyPy. And I thought it's too complex in the design. And many of my goals were reached only partially. So I chose not to pursue that path. When there's Cython, I already commented a bit on that. I do have a high respect for that too. It's a brilliant solution if you want to achieve something that works today. I've developed patches. I arrived there and said, I would like to turn Cython into something that can also be a pure Python compiler, but they were just rejected because at the time they were not open to go into this route. They just thought it was unnecessary because what they have was working. You could optimize by hand your code, and that was all they needed. So I think they changed direction a bit, but not entirely by then. So there was a total mismatch, and the main goal of them was to create extension modules which wrap some library, and there was no focus on whole programs. I write programs, and I want these programs to run fast. It's not about extension modules. So I came up with Nuitka, and it's tailored to my goals. I don't have any time pressure. I don't need Nuitka to be ready to run any program faster tomorrow. It's just, I'm doing it for fun. I can do things the correct way. I don't need any stopgaps. I can't even afford them because I have too limited resources. It's only my spare time. And I wouldn't do things that work somewhat now and replace them with better one tomorrow. So I try and avoid that. It's named after my wife Anna. And the Russians have this habit of giving everybody not the real name, but nicknames derived by making it longer. And so there's Anichka, Anyutka. And then they shorten it again, and they would call her Nuitka in the family. And I thought that's a pretty name. And and one day I made her the compiler as a present. So other people have flowers. I gave her a compiler. And she's married long enough with me to appreciate it. So, choosing C++, as opposed to C, well, I knew about C++ 0x as it was called then, and I thought, well, this may make things a bit simpler. And I thought, okay, it's going to be a while until I'm ready. So it's not an issue that it's not even a finished standard. Now it's finished. And there's a compiler which supports part of it, the part I'm using, the GCC only. But it's also something that I didn't know pretty well. I knew the C++ 03. It's been 10 years, I think, or 8 years when I started Nuitka that I hadn't coded any C++. So there were variadic templates, raw strings, and so on. Many problems. For example, Cython has a huge amount of code for how to encode strings so that the C compiler will have them correctly at runtime. But it's a rather difficult problem to get C to convey blobs and C++ 03. With C++ 11, it's a bit easier, as we'll see, but not entirely. So I made that choice. Yeah, as you can see, for example, the Microsoft compiler doesn't at this time support C++ 11. We have Ming W. I don't know how exactly to pronounce it, which does it. So, and I made a choice for the generated code just to keep things even simpler. Because I'm using C++, I can have this pi object temporary. You see, binary operation will return an object, and pi object temporary will care about the release of it. So I delegate some of the complexity of release and freeing temporary variables entirely to the compiler. And that means I can't really have a pi object and assign it to a variable, but rather always use these instead, and then it becomes rather straightforward. So this is actual code as it is translated. So this is a print statement from Python, and for some reasons I've used a bit and operator. I think because it's not as much optimized. So you can here see the Python C API, and here another call to the bit binary operation. That returns an object which I can ask to give me the pi object and use it here, and then give it to print or item to. So that was pretty straightforward. I would more or less, in the first stage, in this code generation, all that has happened, and all that's possible if you look at the code, because we know nothing about A, B, C, D, except their Python objects. There's no way we can ever do better code by just having this minimal snippet. I mean, we could do better and say undefined variable A. That is, of course, always possible if this was the whole program. So, what else is there to say? With the strings, normally I try to represent them with string, plain, and then the string contents, if that's possible, an identifier. If it's not possible, I use this hash code. And have these as constants. So that's quite readable C++ code, and that's a very necessary trait for me to understand what Nuitka generates and why it isn't as good as it could. So I try to stick that way. That is a requirement inside contained. I have this text, what I said here. This requirement means that I will have to work hard to turn everything into an expression that is an expression in Python. And I notice that it's not easy for everything. So this is one thing, the OR in Python, which for a long time, if you're using Python, you can be entirely unaware that this is actually resulting in either A or B. It's not true or false. It's A or B. And in C++, you don't have it. In C++, A or B is the only expression which comes close to it. It will be true or false. So you have to somehow do something like this. I have a function which is called selective true. So if that object is not null, it will be used. If that object is true, it will be used. It's checking pi is true on that object, and otherwise I will use that. It's using a GNU extension here, because otherwise I would have to use a temporary variable as this code was using. If you look here, I'm having a temp object, and this temp object and its maintenance of variables. Nuitka is relatively free of maintaining local variables. It just benefits from this expression approach. I could stop using this GNU extension and go to here if that was needed, but so far no C++ 11 compiler doesn't also support the GNU extension. So there's no incentive to do it. So via the OR statement, then you have comparison chains. They don't work in C++. Python allows them, and I think it's relatively little used, but it's still a feature that is in the language, because it's very confusing, I find. I do that by introducing temporary variables and assignment expressions, which somehow just work during the expression, and then you get an AND statement. Somehow, this is the least invasive way, and to work with C++ for other things, I needed assignment expressions anyway. In C++, you can assign in an expression. Everybody knows that. If you get it wrong with the 1 or 2 equal sign in the if statement, you have a comparison or an assignment, right? And that's a mistake you can make, but it's also a nice feature for Nuitka to abuse, in this instance, to have a temporary variable and have this comparison chain work with maintaining the side effects. It's very important that G is only called once. Of course, during optimization it may find that G has no side effect, and then it can remove a temporary variable. So, even worse, I'm not going to criticize C++ as much, although I think it deserves more critique than Python. But they decided that there's no try finally in C++. But there is one in Python. So we need to emulate it. And emulation is done by catching exceptions, throwing them, executing the finally code, and then rethrowing the saved exception. More or less, that's also what CPython in its code does, of course. But as we will see, there's also sort of a drawback to it. So one thing which entirely surprised me to see was that continue respects for finally. In C, of course, you don't have that. I never before in a language came across that problem, but of course, yes. Break, continue, return, cleanup is called in all cases. So how do you do that? Well, instead of generating code like break, which is natural for a break, of course, you have to throw a break exception and catch that in your generated code, and then break your loop after executing the finally code. So that's something to work around. Then a very nasty thing, and I think a wonderful thing of Python, is that it guarantees you the order of evaluation of your parameters, and it's as you write it, left to right. In C++ it's entirely undefined, so when I convert this code from above into the code from below, it's not good enough. Entirely unspecified is a bit what the standard says. The reality says that it's just different. It's left to right or right to left, depending on what platform you use. Or what compiler. The C-line compiler, I suppose, for compatibility with Apple, somehow uses right to left too, left to right too, and as does the ARM, whereas the Intel does it and uses a stack for parameters. That's the reason why it does it. Do you have a question?
32 bits
x64 uses registers as
yeah, that's true. But it's still the evaluation order of a compiler remains the same. The AMD 64 is using the same argument evaluation order for arguments than the it's kept for historical reasons, I suppose. So there's no general solution, but what I can do is I define a macro. For example, if I have a function which compare less than, I will define it to call an underscore variant, which I will define with a macro which reverses the arguments as I see fit. So I will always write at core side in one order, and I will just change the function around so that the evaluation order is maintained. Then raw strings of Python are really good. You can do anything there. I've never come across a limitation so far. But for C++ 11, you have something similar. So I told you how the other ones needed a very complex code to achieve raw strings in C++. I personally, I'm annoyed that I have to do this. So it's a raw string, except you have new lines inside, or a zero character, or you have a, well, there was a GCC back. You can encode some characters with 2 question marks, and then we'll interpret what comes next. And somehow they got it wrong, so it's also done inside a raw string, which hurts, right? So I have to massage my string a bit by breaking it into multiple strings, and that works. So,
Can't read it.
yeah, I'm sorry, I can try and bring up the open office for it. Which one is it? Too many terminals error. L-O draw. ODG. Does this like this. And is it more readable? I don't know. I would just have to speak a bit more, I think. Sorry about that. It's a too slow resolution. I blame that on it. On top you have yourcode.py. Your.code.py enters Nuitka. And I have to look myself. Nuitka reads the Python code and follows the import. So it... No, don't mess with it. Don't worry. Follows the import and finds out what your code.py is actually using and recurses if you want to. So then you have a lot of modules that Nuitka will all translate and put it into a build directory, yourcode.build. And main is a problem that is a module that you always have. Constants are there, for example, that string constant that you saw printed. It's accessible from there and has an implementation. And there's a recursed module here too. That is being put through SCons and the C++ compiler, which you practically don't see. I think there's a lot of people who, for unknown to me reasons, hate SCons and prefer other tools. It's just, well, it's just something that Nuitka uses, and it just works. And you don't get to see it. You don't even really have to know it. It creates there's a SCons build file, which will take this yourcode.build and create an executable from it or a module. So you can create an extension module from a code, or you can create an executable. And yeah, SCons is is always started by Nuitka in practice. So that is quite straightforward. Then we have different phases. Your code, we're now looking inside of Nuitka. Your code is first going through a stage that I call tree building. That is taking the abstract syntax tree and transforms it into a node tree where you have while loop. Well, actually, I no longer have while loop, but you have constructs, a variable, assignment, function, module, all in a nested tree, but not like a syntax tree, which is abstract. Then we enter optimization, and there's a bunch of optimizations which will try their best and improve things. They will emit signals about what may now be possible, and it will be running in a loop, doing optimizations, and then do some finalizations. For example, we detect, oh, that is only ever red, that is only ever, there's no try except in this loop, these kind of things that I need for code generation, and code generation creates C++ out of all the modules and puts it into the build directory. So that is how I partition the problem. Tree building, optimization, finalization, code generation. It's also packages inside Nuitka. So to organize the development, now I'm approaching the project, I'm now using the Git flow, which means I have a stable release, and I'm capable of releasing hot fixes the second that I do the fixes. It's quite easy and powerful tool where you can fix things, and it manages Git, so it's pushed to both stable and development version. There's also feature branches working for single topics. So that was, for example, I did a release here, and there were 2 hot fixes. So while development was going on here, I would find things, and these things that I found as bugs, I would already be able to hotfix them and do a release from another feature branch. In this case, I minimized the CPython test differences. That was a feature branch merged there. So it's a very powerful tool, and I think a very good way to support the project. I'm seeing other projects are having a high difficulty to release and can't really get out bug fixes. And I recommend the Git flow. So what's the plan? The plan was to achieve feature parity with CPython. Thankfully, Guido did this language moratorium, so I was capable of catching up. I think I started with something like Python 2.5, and adding the with statement was not a big challenge at the time. So and sets and so on. So added something for Python 2.6 and 2.7, and I'm now fully caught up. But I didn't want to go into status. So feature parity, then I want to generate efficient code from that. So once you have a whole language, how about not being slower than CPython? Because that was what initially happened, of course. There's so many optimizations in CPython that I had to still learn or improve on to achieve speed gain. Then constant operation. Identify as much values as possible at compile time and do that. And then the next, and I think more difficult step, type inference. Detect types in the program and generate special cased code. So we're not no longer only dealing with PyObject, but maybe PyString object, PyInt object, PyList object. When interfacing with C code, I think that's a issue which has the largest interest from many developers. People want this to be easy. I personally, for my bindings, I've used C types. I find that quite straightforward, and for a simple reason, there's no compilation involved. If performance is not an issue, it's quite easy to achieve things. You're done quite easily. And the idea is that the compiler should be able to optimize all of that away, because the specification on how to call things is there. The compiler will just do it without any include statements. You see, it's that's a way to interface C code, I think. Then you have this hints module, which I think can come last. So feature parity with CPython, frame stack, pickling of compiled functions. It's amazing wealth of details in the Python language, and I've achieved that. I never thought that would be possible. But you can get the frame, you can look at things, you can do all these nasty things. And when I set out, I wanted to achieve all of it, but I was not thinking that I would actually do it. But you can still try. And now I know it's possible because I did it. So then we have generation of efficient C++ code. I looked mostly at the PyStone benchmark for a while and brought it up to 260% speed up. So that's something. Then I ran PyBench, and I found that a lot of things are just optimized away. or so fast that you get infinity and you get division by 0 errors in the PyBench and so on. I had to hack it so it could deal with a Python implementation that is so fast. So the only issue is that exceptions are not fast. I'm using C++ exceptions, and C++ exceptions are faster if you're not raising. If you're raising, and in Python that's happening, you're slower. So there's more work to do that. Constant propagation, I have that. Type inference, I'm only starting to do that. PyLint can't help us because it is allowed to make a lot of optimistic assumptions, heuristics and so on. So I can't steal from there. The interface to C code, I had a guy who started working on that, but I don't think it's finished. And yeah, so that's somehow also not existing yet. And the hints module is only an idea. I think it only makes sense when these hints actually lead also to performance improvements, of course. So what's the status? It's known to work on Linux. Well, I didn't say it works on 32 bits too. I did say that, sorry. And it works on ARM. And as you know, with the ABI, I can't tell you it's working on PowerPC without doing that. But because the CLang is working, I have some hopes that it will work. Then you have I can cross-compile to Windows, which is quite convenient. And you can do Windows native. That's mostly done by other people, because I don't boot a lot of Windows these days. So, actually not in the last 10 years. So, yeah. I did it for games, and only recently I did it for Nuitka, occasionally. So, Nuitka needs Python 2.6, 2.7, and if you're a Python 3 fan, you may be happy that Python 3 can run, for example, Nuitka can run Nuitka in Python 3. That is a huge test, and I can run my basic tests in Python 3. I didn't run the whole test suite yet. So, yeah, G++ in all of these recent versions, the ones with C++ 11 support, and CLang 3.0 also works. Current activities, I have type inference going on. There's a speed center revival. I'm now starting to benchmark again. For a while, and I think I will show that, for a while I stopped doing that because the diagram, had I done it, would have looked like that. You see? Smaller is better. That is the ticks. I'm using Valgrind ticks to measure the performance. So I don't do 100,000 runs and measure the mean time. Instead, I just ask Valgrind what it thinks how many ticks it were. And you can see lately it has been approaching previous levels. The bump ups are because I became more compatible. For example, I would maintain the frame stack and so on. So, as you can see, there wasn't really any progress, right? So it's not much fun to look at performance diagrams when you're level. Yep. So that is a project. I have the XML dump here. I'm using that to find regressions when I do optimization changes. So I will output my internal tree in XML. I'm actually using LXML and diffit and find when I do this, does it have any regressive impact on the other things. Lessons learned. Equality with itself is not a given. That's, I think, an entirely flawed trait. But it is like this. Equality cannot be assumed. Then you have nested comprehensions. Not a lot of people use that, but it's there. And yield can return values. I think that was introduced sometime during Python while I was not looking. So, yeah, it works. Then I'm making language conversions, and I think I would like to cut 5 minutes from the questions. The assert statement, I think Guido mentioned it yesterday. That is what Nuitka does to it. I'm making that an actual conditional check, and then I raise assertion error, comma, argument. That's equivalent. So I used to have an assert node internally. I no longer have it. So I started rewriting some things and other things, and the assertion is really just a condition. And that way, optimizations that I have for this condition, they just work. So this assertion got optimized out when value is not true, or is true. Then I have generator expressions, and I just turn them into function. I used to have two implementations, one for generator expressions for C++ code, and and one for functions. But it's not needed. Contractions are the same. I just make them into functions and compile them, and it's the same thing. Then we have the comparison chain from above, which I practically already explained with the temporary variables. Exec file. It's equivalent to this thing, with the advantage that my code optimizations looking at files which are opened, trying to preserve their content, which do not yet exist but may exist in the future, will be able to see it. And no more exec file exists. When decorators, I used to have an attribute to function which was a list of decorators, and then when I generated the function object, I would call the decorators with their arguments, which was entirely stupid. Instead, I'm now rewriting it to be more equivalent to this thing below. The only difference is that function didn't have an intermediate value with a decorator. So no more decorators, the same for class decorators, of course. When in-place assignments, I'm adding temporary variables and then temporary Python variables, which will not be visible in locals and so on. And I will just call it like this. And there's no more in-place assignments. There's just assignments now, which is a tremendous simplification. You cannot imagine the relief when I realized that I do not have to deal with these anymore. Complex assignments are absolutely trivial because of the way it handles exceptions. Once upon a time I thought that it's somehow in a transaction that I couldn't assign B and A. Somehow it looks incomplete to me. No, it's correct. But I couldn't assign B but not A, or the other way. But it's not true. The exception just, when it happens, and both of them are assigned or none of them. Here you can see why exceptions could happen, because the complex assignment from targets. I use a temporary variable, I do iterate over it, create temporary variables, check if the length is okay. So that's things that I think CPython does in the bytecode already. And now I'm having this in my node tree already, which is probably not much of a surprise. But when I'm looking at optimizing things, this is the end of it. It's actually a large thing because I think I have nested. Yeah, is it nested? No, I have combined. I have a sequence. The result of H is unpacked to multiple things, to one thing, and to a complex thing. So, as you can see, no more assignments. Then with statements. Yeah, with statements, you just look up the exit and enter. For some reason, the exit is looked up first, then enter. Then you do it, and when you catch an exception, you raise it, and when you don't, you call exit with none, none, none. And you're done. There's no more with statement. No complexity from that anymore. For loops. Well, it's simple. You just take the iterator, you track if you if you iterated to the end or not, and then finally you just add an if statement with the otherwise. And that is it as far as a for loop goes. You don't have a for loop anymore, you have a while loop. And while loops, even that I remove because I move a condition to inside the loop. So there's only a forever loop, and you have to explicitly break it somewhere. And I will look at the breakpoints, and it cannot be only at the beginning, but in the end, and it will be the same. This loop analysis that does things, it will these codes will be equivalent, except of course that it will make the problem of optimizing this a bit harder, because you have to have a good analysis of the exit points of a loop. Then exception handler values. This syntax here, I had something more complex, and then I decided to rewrite it and just assign it to a variable e. It's not really doing this, it's looking at the exception object, but yeah, you just have try except an exception type, no more assignment. Just move it into the cached code. And of course, yeah, try else branches of exception work similar. You just track if the exception occurred or not, and then execute the else branch. Or class creation. There is no more classes then. I don't think I'm really finished with this one in the code, but a class is really only a function call, where that function here with exec forces it to keep a dictionary of the locals, and then you just define here the class members, return it, hand it over to a make function, more or less type, and hand it the basis, the name of the class, and the dictionary. And that is it. So there's no classes. Of course, understanding classes will ultimately help the compiler, but it's not needed to see things. So if you would like to join, you're very welcome. Not only welcome, but very welcome. I can take a lot of help. I think the project has reached maturity. I think it's where I have most of the things in place. I think I need more work on the benchmarking and so on. But I accept patches in whatever form. I will do the integration work myself. You can base it on tarballs that you find master develop on any given time. And I will integrate it, because I know that's normally the hardest part. And it will be easy for me, and I will review the things anyway. There's a mailing list, there's RSS feeds. And starting with EuroPython, now I've chosen to set free Nuitka. Before I was under GPL free, which meant that nobody could take it away, fork it, and make it a commercial product, or take it into a direction where it wouldn't achieve all my goals. Now I'm confident that this point is too much of the work, which is unpopular, has been done by me, and I put it under Apache license 2, which basically means you can do anything you want, except suing me. And I think something about patents, so that is all you have to do. You can use it for all software. So I will be here for all the week. I welcome questions and ideas in person. Actually, that's the only benefit that I have from this project, is that feedback. Questions are welcome by email, mailing list. My hope is exchange with PyPy developers. PyPy tests run might be somehow useful to me. I would like if people looked at the design and the code review, or tell me what I've done wrong. Ideas from C++ people, so if you have some knowledge, and I know there's also people who have that, if I suppose people looked at the code, it would help me. Presentation created with RST to PDF. You can download it already. I uploaded it to a website. And diagrams with, yeah, that is it. So thank you for listening, and I'm hopeful you now have no more questions, or just good questions. I shall repeat the question.
Questions. A question at least. I would be very interested. I probably should be given a microphone.
I will repeat the question. I think that's the idea.
Okay, what I'm interested in is, given your approach to the problem of generating code, is probably have to run within the context of the normal CPython runtime.
That's true.
How does it deal with things like threads and?
I have a bug tracker, and one of these things which is on the bug tracker, I do not. I think I agree with Guido on this. I do not care much about threads, so I just didn't do it yet. You have to take the GIL somehow, somewhere. I just lack the knowledge of how I should support that. It's not that it's not possible. It's on the level of it's amazing that I don't know after all this what I've done, but I don't know how to do that. So, and I don't care. But I'm quite sure. I'm quite sure it will be done. Surely, the multiprocessing module uses threading, to my surprise. So I will have to do it. Yeah.
Okay, thank you.
Okay, I have one comment and one question. First of all, you don't mention the shetskin.
Yeah. Okay. Sorry for not mentioning. I have a very high respect to shetskin. It's also something that I tried, but the offer is it has no try finally. It has it's created by Marc Dufour. I have contact with him, and it's a great thing. But I think it's he targets more of the C++, writing C++ in Python. It's not, he integrates well with C++, and he has. I think it's on my list of activities in the presentation that I want to run, and actually it will be the thing that I compare to. Activities is I tell you, I did. Do that. Yeah. Table of contents can be so great. Where is it? Shetskin. Yeah. The Shetskin tests. That will be the thing that I benchmark against. Because Shetskin can do has a very restricted Python, has test programs of some sort written in this very restricted Python variant with no try finally, no mixed types, no nested function, no. Really, it's not. He's not trying to be Python, but he's trying to have a language which is convenient to use and generate C++, which is integrated with SCL and so on. And he's amazing. He's achieving amazingly fast programs. And my first benchmarks that I will run in comparison will be to look. He had a look at what's possible with a restricted subset, and I will look at with this restricted subset and my being general, where's the conflict, or how can I understand these programs in the same way, and then I will have achieved some. So Shetskin, it's not. I didn't leave it out because of for lack of respect. I just noticed very early on that it will never run an existing program, and I had contact with him, and try finally is not. It's not intended because C++ has no try finally, and the argument tells you the direction.
Okay, and one question. Actually, there's a lot of internal differences between C++ and Python.
Yes.
It's like actually C++ compiler can rearrange the elements of the or and expressions. So if you write and A and A, B, they actually can rearrange and regulate in any order. But in the Python, it's
No, there's a sequence point.
Because it's a short circuit evaluation, so you can check if something's null in the first half and then use in the second half. If you flip those around, you get a second one.
You write A and B in C++.
Yeah.
Yeah, and compilers somehow understand that.
If it's a single AND, if it's double AND, it's a short circuit operation and it can't rearrange it.
No, I mean, and is
The single.
The single one,
Oh, they're
the one I used in the example.
and I mean, they actually can even calculate in different order. So if they somehow understand that B is should be integer, they will definitely rearrange them and never calculate the A. I mean, they can never calculate the A, and it's harder to achieve in Python.
If it's a short circuit, if it's the non-short circuit rate, it has to evaluate first.
No, I mean the N.
Unless one's minus one. Yeah, I suppose if you minus one or
They will not calculate.
Maybe I can try and give my answer. I've looked at the question is largely about sequence points. I think your concern is that.
Short comments like if you have
afterwards. I think I'm getting off topic here.
Yeah. No, don't. It's not that important, I think. I've looked at sequence points in C++, and you have sequence points, for example, at function calls. You have sequence points for OR and AND operators, the short circuit one. You have it for the ternary operator. You have it in enough interesting places so that I will be able to avoid the reordering of a Python code. I never saw reordering of Python code yet. That was not my fault. So the C++ didn't do that to me yet. It's in theory it's allowed. I see that it's a problem for C++ programmers, but I just generate C++ code, and if I have that, I can just introduce something which will add a sequence point. It will be solvable.
I mean, you don't even know would it become when you make the function call, like A from B from C from D, you definitely know that all arguments would be calculated. You just know the order of operations. But when you write in C++, A and B, you don't know would B would be ever calculated. Because if they somehow understand that B is 0, they would never calculate the B. If you have like A and B from 1, B from 1 can be never called.
It's okay. For me, it's okay. I think we can. I think the compiler will survive these difficulties. I will try to do. It's possible. I contend that it's possible. If you disagree, yeah, I do not believe it. So next question, please. Sorry for being rude, but it's a lot of time wasted.
What about Eval?
Eval is working. exec is working.
So how do you
exec file is working.
how do you do it?
Actually, I provided with a dictionary. Eval. The question was whether Eval is working, and I provided with a dictionary as I'm supposed to. Modules and locals, variables, dictionary, and then I copy things back and forth.
So how do you actually evaluate the code? Do you just call this?
See, the libpython that I use can do it. There's a call PyEval that.
So that doesn't get optimized?
In the beginning I had a code that did it for constant strings. And actually it's useful for programs which, a lot of programs I think generate some strings and eval them. They probably shouldn't, but I've written such code too, so it seems to happen. And that will be optimized and compiled.
So I did solve the problem you showed at the beginning that the continuous lookup to the global environment, so len equals len. Have you optimized that thing? So,
Yeah.
how did you do that? If it's short, so we can expand.
I just look at the uses of len, and I know that it's the global thing. And then I have my own implementation of len. And my own implementation is faster than the built-in len.
So, do you have to analyze the entire program at once in order to compile it? Because otherwise you wouldn't know if somebody actually swapped in a different len or swapped in a different meters per nautical mile or something.
Yeah, actually to be sure that a global variable is constant, I have to look at the whole program.
Okay. So
And
you change the global variable inside of the Eval, and that's
yeah.
the program is no longer compatible.
If a library change, you mean? Or?
No, if I had a program that used an eval, and inside the eval I change the global variable, and it is something that you have optimized, then I have, then it is no longer compatible.
Yeah, that would be mean.
You can do it. You can, as far as I know, you can assign a new variable inside the eval. You can do an A equal B.
You provided the globals. You can.
All built in, built in dot len
Exactly.
equals mine.
You can
Exactly.
write them in the routines, the namespace.
You're right.
You can replace len, ren.
Probably optimizing normal
So
for real work.
the real work aspect, I've compiled Mercurial, and Mercurial, as you can see here, this is a compilation. It took 7 minutes, about 7 minutes to compile the whole thing. It told me about a few things that it didn't find when it wanted to recurse to, and it told me about these plugins. I should provide it with a directory where the plugins live to be fully using the compiler, but I didn't do that. And then it just runs. And I've used the Mercurial, and I have to admit that the test suite of Mercurial is not yet passing, largely because of order things. So I have a couple of bugs, obviously, that I didn't find yet. And but Mercurial is a bad tool to find them, so I will have to come up with ideas how to do that. So but the idea, of course, is it's largely usable. I mean, it's only a couple of tests failing. I don't know. PyPy would be happy with some on for tests only failing. For some things, I've seen that. Yeah, it's. I'm not saying it's usable, or I'm not saying that if you try it, that your program will be faster noticeably. I'm just saying that the ground is laid out, and that if developers want to join this effort and add optimizations and make it do useful things, this is a good time to do it. That's why I'm here.
What about debugging an application compiled? Because I mean, compile application running maybe it's not the same as a script running.
Yeah, that's true. The question is about debugging, how that affects. When I'm debugging, I'm using the GDB, and I just debug it as a C++ program, and there's always line information nearby. So if you look at the code, let me go here, functions build. There's line number information, set line, like this. So that's quite typical code that is generated. Sets a line number, and then I correlate that to the Python code. But if you just run the program, you get a normal traceback. So no, it doesn't. I think I don't know is the correct answer. It will just give a traceback. Actually, there's tests, syntax, Nuitka, class return. Yeah, it will just give tracebacks as if you were using CPython. The tracebacks will look the same. But if you have a segmentation fault and so on, you have to resort to C++.
We have also some kind of annotation. I mean, in Cython you have in the translated code commented section of your original code, so you can.
No, I don't do that. I found that just. I don't do that. I found that a bit unpractical. Yeah, please.
So, what else besides threading does not work?
Okay, I have a bug tracker, I told you, and
High-level things, like built-in modules that don't work yet, I say.
no, all the modules work.
Except threading.
PDB is also built in, right? Although test PDB works, I don't know if that means anything though. Maybe it works, and I just don't know. But actually, I don't know. I'm just compatible, you see, and these are the issues. It's using in tracebacks for function calls. It's using the start of a call versus the end of a call, like CPython does. In CPython, if you have a call spawning multiple lines, you just get and it's just a brace. You get the brace. With Nuitka, you get the called thing, which is even better. The thing is, I would like to be compatible. I just don't know how. So that's not working. And func code, the bytecode is not there, and the defaults are not writable. So if you would have something that changed func defaults and expected the default to change, that wouldn't happen. Oh, that's working. What's not working is that you have an attribute to every function that lists the defaults, and if you change that, and when you call the function, don't give a value, that one is used. So that's a rather esoteric thing, and I don't have code lines, but I can resolve these tracebacks. Yeah, representation of some things, and you don't have a constant of a function. It's really, yeah. I mean, sorry, but it's. I tell you, I will be caught lying, but I consider it complete for support.
Do you support tracing?
Yes. Which tracing do you mean? I misunderstood you. The set trace, I'm abusing the tracing myself. I'm using the. You can set a trace function, and if you do that, you get to specify in the frame there's a line number field. I'm using that because I do not generate bytecode, which will be resolved in case of exception for the line numbers. And I'm abusing that right now. It's possible to also support this tracing, and I think that would hurt PDB. No, but something else maybe. Yeah, no, no, I don't support that. But it would be possible. But I'm now right now abusing that to be. Yeah, it's the cheapest way to support line numbers. The set line just in a frame sets the line numbers, and regular CPython supports that in case of a tracing function, and they have a collision. And otherwise, you have to have a table where the current bytecode position is resolved to a line number. I would have to emulate that, and then I could set free this field.
So you don't support LNO tab then?
No, exactly. That is, of course, it's feasible. It's just a nasty job to do, and somehow in my mind it feels slow to have to resolve the line no tab when you just the code has an else if branch. If that is not none, it will be fast, and otherwise it will go into the line no tab. So it's almost like an optimization. You get at the line number immediately, or by looking up.
Right. Well, the reason the LNO tab is there was an optimization, so that you weren't. There used to be an opcode, a bytecode that said, now we're at line X, now we're at line X.
Oh, okay.
X, and that actually had overhead, and so getting rid of those was faster. And the only time you have to compute the line numbers is when you're hitting an exception, you're computing a traceback, at which point that's not performance sensitive code.
Okay, I probably should emulate it because now I have a function which is called setLineNumber, and I call it all the time. Yeah, but in C++ it doesn't hurt that much. I suppose it's inlined and so on. But it's true, it's an optimization.
Do you support the changing mutable types that you get from the locals built-in function?
Yeah, sometimes you have a writable locals dictionary, sometimes you don't, and it works both cases. If you have an exec in your function, it becomes writable, and that's supported. So, yeah, these exec eval tests, they all work as expected. That was a bunch of work. Unicode, and so on. And Python free. So if there's an Python free expert who wants to join, it's fun, and we don't have a lot of stress. Yes, I do run the Python test suite. Tests. I do have a public repository, not basics, CPython. Actually, I only have done it for this version, and this takes every single test and just compiles it with my current checkout, and runs it in Python and in CPython. For testing, that's something I didn't say. I have a very easy testing. I ask Python, what do you do? And then I compare it to Nuitka, what do you do? And if it's the same, it's correct. If it's not the same, it's wrong. So my testing can just, I have code that does a bunch of things and then prints out the result. And I don't care if it's Python 2 or 3, behaving different, or 2.5, 2.6, 2.7. I would just, I think it's called testing by Oracle, or testing by, what's the other thing? Well, basically you can predefine the expected test result, or you can have an Oracle which will be able to tell you the result. And that's, we have a good Python implementation available that can answer all these questions, so I don't have to write anything up. So on the testing side, it's quite easy. Yeah, so getting through all of these for the first time, I made it by the letters. A, B, C. C was quite terrible. I think it was called test compiler. Test grammar was also nasty thing to achieve. So all of these work, and I have a Git repository with, I think, a few commits where I've annotated with issues. I describe why I changed the test. And sometimes I did that because of a line number issue, and so on. So, another question. Yeah.
From a user point of view, I tried to compare the package Nuitka. I was just
How to import it? Oh, you just place it in your Python path. You just import your module name. Ah, you had a package. Okay, that's more difficult. Maybe I would take that as a hint that I should write better documentation about how for these use cases. I think I can't really answer that right now. Sorry.
Can I call the import function?
Yes, you can, and Mercurial does. And I'm compatible with all the nastinesses. That Mercurial has a cache of modules. So Mercurial tries to not import all the things immediately, but instead provides proxy objects and imports and caches things. And it does abuse all the features of import. And I got that to work. Yes.
So it's, at that point, you're basically running in the Python interpreter in libpython, yes?
No. I'm just have a compatible implementation that does the built. I have a built-in import of my own, which works. And if the Python uses import, I work too. I register my modules.
So you've overwritten also the inf module.
Yeah.
Define module.
Yeah, I did both. I have my own implementation, and I'm compliant. There's a way, I think it was a PEP, you can register as a meta loader. I forgot the PEP number, but I register as a loader for modules, and then my frozen modules, the compiled ones, which I include in the binary, a library can import them. That's not an issue.
Okay, but you can still run just normal Python code, yes.
Mm. Yeah, it integrates well. So the issue is mainly now getting this type inferences sorted out, comparing to shed skin, and to become actually fast. And then make PyPy developers sad. Yes. Which will not happen, unfortunately. You know how it goes. You will say in 3 months we will have that, and then you will have a slide 3 years later about it. But now, it's this project is young, and I think a year from now it will probably not be very much faster yet. So, next question.
So, just expanding on the last question. If at compile time you not import a module because this uses the import function and the code is just not there yet, and at runtime it tries to import something you have not compiled yet, what happens? You fall back to Python?
Mm-hmm. Yeah, CPython is then going to execute the bytecode of that PyC compiled. Of that, on its own, and it will. You can switch back and forth between compiled and non-compiled code freely. I have compiled function objects, compiled method objects. Classes do not have to be compiled; they're just objects, and they integrate with the Python type system, behave in a compatible way. My compiled function type is fully compatible to the other one, except its representation. I chose to not say function because I will get insane if I can't recognize if it's a compiled one or not. So, yeah.
Do you have a special handling for the match common for I in range constructs?
No special handling for that yet. But in principle, I have special handlings for plus, minus. I did some of these things, but Pystone is using. I looked at how far do you get with this is being a very close friend to CPython. I'm going to be the slave of CPython. So if CPython fails with Python 3, I'm failing, right? So yeah, that's true. On the other hand, it will always be there to help me, and I will look at the code and I can abuse internal knowledge. For example, module variable accesses are slow, but with Nuitka they're much faster because I'm scrupulous enough to take advantage of implementation details of CPython that haven't changed, not even in Python 3, but and then you can't be much faster than CPython is. with modular variable lookups if you're being a close friend to dictionaries, and string dictionaries in particular. And that's often used with code. And I do a lot of these tricks. And the in operator, I'm optimizing with as constants and so on. I can optimize that at compile time. But I'm not yet doing a lot of useful things yet. What I did, I think an important example, if you do this len, well, you wouldn't do it that way, but if you do that, it's going to take a while. And I have type inference up to that level that I have the ability that len asks this thing, how long are you, and it knows I'm, 10 million, my length is 10 million, and this will be a constant in my code, and I suspect, you can correct me, that the JIT will have to execute it once to know. No? Oh, occasionally I will try. And yeah, this is the curse of having to. Oh, it got killed. Well, who logged in on my computer? Yeah, the range generation. Yeah, it has a bit of memory.
Unfortunately, the time is finished. So if you want have another question, maybe the coffee break.
As I said, I will be here all the conference. Thank you so much.
Maybe you can try to fork the code. Just like if the range is the class built-in, you can generate a special code which knows that it's not. You can use integers.
Yes, exactly.
I'm
I'm not entirely